right, example number 1. This is what you would expect to have on like a quiz. Okay, you're going to be given a polynomial. You're going to have to sketch it and then describe its end behavior. So before we sketch it or anything, let's practice using that cheat sheet. So what is this polynomial g of x? What's its degree? Its degree is 4. So let's write degree is 4. Which, when we're looking at the degree, all we care about is it even or odd. Is 4 an even or odd? So this is even. Okay? What's our leading number? What number's in the very front? 6, yep. Our leading number is 6, which is positive or negative? Positive. Okay? If we go back and look at that sheet we just made, we have even and positive. Let's go find what that would look like. Even and positive. What's my graph going to do on both sides? It's going to go up on both ends. Because that polynomial was even and positive, we know this is going to be its end behavior, and we didn't even have to graph it. This is what it's going to be. The left side's going to go up, and the right side's going to go up. Okay? This is like your big cheat sheet. Okay? So, let's find our sketch. But we know the left side and the right side should go up. Okay, so if I turn this bad boy on, clear this out, 6x to the 4th minus 3x to the 3rd plus 12x squared. This is a long one, isn't it? Plus 8x plus 2. Graph it. Look at that. It looks just like a quadratic pretty much. I can tell on my graph the left side's going up and the right side's going up, even though that's a big, long, complicated polynomial. All we had to do was look at that first term. Okay, so your sketch again, it doesn't have to be a work of art. Just get the gist of it. And what? It looks something like this. And just like we had said, the left and the right side go up towards infinity. So let's write our rule. This time our function is g of x. So this is for the left side. G of x is going up towards infinity as our x values, these are our x values, as x goes to the left, so negative infinity. Again, it's exactly the same as what we did, except this function is called g of x instead of p of x. For the right side, g of x is also going up towards infinity as x goes to the right side, which the right is going towards our positive number, so positive infinity. And that's our end behavior. But, again, we didn't even really need the sketch because those 4 boxes we fill out on the other page describes the 4 possibilities. And it's all based on the degree and the number in front. All right, what do we got? One more? One more. Okay. Ooh. 9th degree. A 9th ninth degree polynomial is called a nonic, if you didn't know. Our leading coefficient, our leading number, the only thing we care about for end behavior is negative 5x to the ninth. Means my degree is 9. But we don't care how big it is. We only care, is that even or odd? 9 is an odd number. I know that because if I had $9 in all $1 bills, me and Kravitz could not split them evenly. I'd have to give Kravitz 5 and I'd keep 4 because I'm a nice guy. The leading number is negative 5, which is negative. Again, I don't even really need the sketch because if I just take a couple seconds and go back a page in my notes, odd and negative, odd, negative. My graph is going to go up on the left and down on the right. I know for a fact. We'll double check. Okay. Last time, calculator out. Click on your y equals. Let's type in this long guy. Negative 5x to the power of 9 plus 6x to the power of 7 minus 5x to the 4. Isn't it crazy how long polynomials can get? X squared minus 1 graphic. And just like we said, the left side goes up and the right side's going down. The middle looks a little wonky there for sure, but the left is going towards positive infinity and the right is going towards negative infinity. I want just like that. Again, it's a sketch. You don't have to worry about sitting there and making it perfectly accurate. My left side is going up. My right side is going down. So if I'm describing the left side, and again, it's going to be exactly the same as what we did on that page before. But this function's h of x is going towards positive infinity. It's going up. As x, this is describing which side as we look at the left side. So as x goes to negative infinity. This whole thing right here, if this is still confusing, this just means the left side in math. When x is negative infinity, on the negative side, that just means the left side. That whole thing is just a way to write the word left in math. So that'll always, whenever you're describing the left side, it'll always be x approaches negative infinity. For the right side, h of x approaches, on the right, we're going which way? Down, towards negative infinity. When we're describing the right side, we're talking about all the positive numbers, so positive infinity. And again, this is just a fancy math word for saying to the right. And that's end behavior. Okay? The big thing is that table we filled out with the 4 boxes, those are the 4 possibilities. There's no other possibilities. It's going up, down, up, or down, down. No other combination. Just by looking at that first term and being able to go look at that notes paper, you'll be able to do your end behaviors. And that is all she wrote.